Hi, everyone. Today's lesson's on sinusoids. This second half of chapter 5 of our trigonometry chapter. So we're going to be graphing sinusoids. Sinusoids are graphs of sine and cosine, tangent, and other of our trig functions. So let's get started. We're going to start off with a warm-up in finding 5 trig ratios for this question right here. It says if cosine of x is equal to negative root 3 over 2, here's a little bit of a restriction that says pi over 2, x has to be in between pi over 2 and pi. So what that means is if this is pi over 2, and starting here going around pi over 2, and this is being pi, it means that x, our angle, is going to be in between here. And keep in mind that because we're using x as opposed to theta, we are in radians. Our answers will be in radians, or at least our functions will be of the angle. So what we need to do is first find this angle. This is asking me x is equal to arc cosine of parenthesis negative root 3 over 2. So it's asking me where is cosine negative root 3 over 2. So I'm going to put this in the second quadrant, and I'm going to say, well, cosine is adjacent, so that negative root 3 adjacent over hypotenuse. That makes that a 1 using the Pythagorean theorem. This angle here is going to be our reference angle. That being said, where are we? We want to know where we're at. Well, across from 1 is going to be our 30 degrees. And what that basically means is that if this is my reference angle, theta reference, you can either put the reference here, you can also show it by putting a little slash there, theta reference. This is then the angle is 150 degrees. Now you can use your formula that looks like this, theta equals 180 over pi times x, to change back and forth between degree and radian measure. So the 150 would be here. You would multiply by pi over 180 to get x by itself. In addition to that, you can just pretty much think in your head that, 30 divides into 186 times, which means that from here to here, that's actually pi over 6, which means that from here to here, if this is a whole, this whole thing is one whole being pi, that this distance here is a sixth short of being a whole, which would make that 5 pi over 6. So our radian measure, so for x, is going to be equal to 5 pi over 6. Although we know that theta is 150 degrees, let me fix that. That's not a reference. Theta is 150 degrees, where our reference angle is 30. All right, so your job is to find the other 5 trig ratios. So I'm going to put all of them on here. The first thing I'm going to use is cosine of 5 pi over 6 is going to equal negative root 3 over 2. We know sine of 5 pi over 6 is 1/2. We know tangent of 5 pi over 6 is equal to opposite over adjacent, which is 1 over negative root 3, which is negative root 3 over 3. We know that cotangent of 5 pi over 6 is equal to tangent, the reciprocal of tangent. So that's going to be, instead of opposite over adjacent, it'll be adjacent over opposite. And so that's going to be negative root 3. The last two are secant of 5 pi over 6. Secant's the reciprocal of cosine. So we're going to flip negative root 3 over 2. So that'll be 2 over negative root 3, or negative 2 root 3 over 3. And cosecant of 5 pi over 6 is a reciprocal of sine. Sine is 1/2, and so that's going to be just 2 over 1. So graphing sine and cosine graphs, again, we call them sinusoids, are useful. Sine waves or cosine waves, these waves are useful because we use them for, sound waves. We use them to regulate, find environmental issues, and we can look at music. There's a lot of ways you can use a sine wave, and I don't know all the ways, but I know they're pretty important. So how is a sine wave related to a unit circle? Now, I've been saying this for a long time that I'm going to unravel the unit circle. So I found this really neat website that I'm going to go to real quick that I think that you're going to like. And they do show you just this. There's not any sound on it, but they does show you that you take your unit circle and they're basically unraveling it and making it into a sine wave. So this is sine wave. This is a sine wave. Let's see. I'm not sure if that gets wider. There we go. Oops. Okay. And also we have a cosine wave. Remember, cosine starts high, ends high. It starts high at 1, ends at 1. So this is kind of a neat thing. I thought you'd like that. Unraveling the unit circle. All right, so here's our sine function. And with our sine function, what do you notice? Sine wave starts here, goes up, starts at 0, goes down, comes back up, ends at 0. But the question is this really ending? Or does it keep going? What's happening here? Because obviously it does have a back part here. What's happening here? So hopefully some of the things that you've noticed are that this sine wave can go on forever. But before it does start repeating itself. See how it goes 0, comes up, goes down here, goes up, goes down, ends at 0. What's happening is it repeats itself, and we call that periodic. Okay, periodic. And if something is periodic, like let's say a function is periodic, that means it's going to repeat itself. But what you would want to ask yourself is, how long does it take before it starts repeating itself? Okay, we call that a period. So how long is the period? Well, in this case, we're going from 0 to here, which is either 360 degrees, if that's 0 degrees, or 0 to 2 pi. So the length could be 2 pi, or the length here would be 360 degrees. Before it starts repeating itself, so that's something that maybe you noticed, besides it starting at 0 and ending at 0, meaning this would be 180, halfway through is 90, halfway through from here to here is 270 degrees. The height, 1, low value, -1. We call that a minima and a maxima. So sine function here has all this really cool stuff here. What I do want to remind you is this kind of thing, it goes from 0 to 2 pi, and we're good at, this is now pi. Halfway in between 0 and pi is pi over 2. Halfway in between pi and 2 pi is 1.5 pi, which is 3 pi over 2. What you haven't seen a lot of is that these are our coordinates as we go along. So at 90 degrees, we're at pi over 2, 1. It's the same kind of thing that if we were drawing our unit circle right here, and look at all these cool colors. Okay, so if we had our unit circle, this would be 1, 0. This value here is going to be 0, 1. This is going to be -1, 0. And this is going to be 0, -1. Well, here at 90 degrees, we're at pi over 2, 1. Now, what are those values? That's a point. I just put 0, 1 here. Where did this point come from? And hopefully, what you're thinking is that this value is cosine of x, and the 1 is sine of x, meaning in this, usually when we put our point values, okay, where our points are x, y. So these are our x. So at pi over 2, right? Oops. At pi over 2, let's say here, this is pi over 2. At pi over 2, sine is 1. So pi over 2, comma 1. That's that actual point for sine. And here for pi, this is going to be pi 0. See here, pi from here to here is pi. Sine is 0. So at pi, sine is 0. For 3 pi over 2, which is down here, we have 3 pi over 2, comma, negative 1. So that's where that comes from. Okay. Keep in mind that in this equation for sine of x, if you are using x, you're in radians. If I would have said y equals sine of theta, then my values would be 0 degrees, theta less than or equal to 360 degrees. And I would put it like that. Some vocabulary for our sinusoid. Amplitude is what we call the height. Okay, so this distance here is my amplitude. Okay, in this case, it's 1. This height is 1. It's the absolute value. So it's always going to be the absolute value of that. So the absolute value of my height. Okay, it's the length. Lengths are positive. So that's my amplitude. Amplitude is the height, the distance from the median, which is this axis here, to either the minima or the maxima. So this is my maxima, and this is my minimum. Okay. Zeros are where my graph crosses the x-axis. Okay. So I'd have a 0 here, a 0 here, and a 0 here. Now, a phase shift can be a couple of things. Okay. We call a phase shift is basically a horizontal shift. Okay, and what that means is that I can take my axis, which is right here, and if I were to move it, let's say this way, that's what we call a horizontal shift. And hopefully some of you are looking at this and going, oh boy, what I just did was I moved it to the left, and now I have a cosine graph. And I moved it to the left. Let's see, how far did I move it to the left? Hold this point right here. And I moved it 90 degrees to the left. And now I have a cosine graph. Well, that's a horizontal shift. We also have something called a vertical shift, which goes up or down. Okay. And a vertical shift will go up and down, and a horizontal shift will go left and right. So getting back to this right here, if I started back off with my sine graph, sine wave, vertical shifts will either go up or they'll go down. Phase shifts or horizontal shifts go left or right. Cosine function, same. We have a lot of information about a cosine function. Starts at 0, drops down to -1, starts at 1, goes down to -1, ends at 1. Starts high, ends high. Still has what we call a period. This is our period. The length of time it takes for me to start and stop and before I repeat my graph. So the length it takes for me to complete one full cycle. That's what we call a period. The length of time it takes for me to complete one full cycle is a period. Okay, cosine function, same kind of thing. Goes 0 to 2 pi. Amplitude, 1. That's my height. Height, height. In this case, remember on our trig functions all the way around, let's say at pi, here's pi, cosine, so at pi, cosine is -1. So this value here, which was -1, 0, remember our points, cosine, sine, okay? Cosine at pi is -1. So at pi, our value is -1. Likewise, at 2 pi, so go all the way around, here we are at 2 pi, at 2 pi, cosine is 1. Okay. Again, the period is the length it takes, of time it takes to complete one full cycle. My amplitude is my height, my maximum and minimum, my minimum. Zeros are where my graph crosses the x-axis. Again, phase shift. So just keep in mind a phase shift, if this is my graph, okay, a phase shift will go sideways, go this way, which is, if you're noticing, dropping down first. That's a negative cosine graph, or excuse me, negative sine graph. Anyway, going back to my phase shift, moving this back over, going left or right, that's a phase shift. Up or down is a vertical shift. So sine waves versus cosine waves. What you should know for these two things is that a sine wave, which starts at 0, goes up, comes down, and ends at 0. Okay. Cosine waves start high, go down, come back up, end at 0. So the difference between the two is 90 degrees. They are 90 degrees apart. And so, whoops. So they're the same graph technically. I can't get it back on there. Anyway, okay, moving on. So there is a Desmos Exploration that I'd like you to try. One thing though is when you do this and you go to Desmos, you do need to set the step to pi over 2. But if you graph a sine wave, the question they're going to ask, I'm going to ask you all these questions. What do you observe on a sine wave? Okay, so you should observe that it does start at 0 and it ends at 0. What are your zeros? Your zeros go here at pi, 2 pi, and at 0. Does the graph repeat? It's going to repeat if it's continuous. How long is one cycle? One cycle would be 2 pi. If it's a sine graph, it's going to rise first and then fall. Our maximum and minimum are 1 and -1. Why does it keep repeating? It's because it's periodic. And where does it increase or decrease? So it increases from 0 to pi over 2, and it increases from 2 pi, etc. And where does it decrease? It decreases from pi over 2 to 3 pi over 2. Okay. So a periodic function repeats itself, and the period is how long it takes before it repeats. Periodic functions, this looks like a heart monitor. This right here looks like, I don't know, maybe a truth table or something. I don't know. Are the following functions periodic? And if they are, what is maybe they're asking me the period. The period is the length of time it takes to repeat itself. So if it starts here and it starts over again, this length of time here is the length of time it takes to repeat itself. So we have something, we call this a VAF, VAFHP. And this is another mnemonic, and it's a mnemonic to help you with graphs of sinusoids. And we're going to do a lot of this the next time I see you in class. But V stands for vertical shift, A stands for amplitude, F stands for frequency, H stands for my horizontal shift, which in the other page we called it a phase shift. In a sine graph and a cosine graph, we have a period of 2 pi radians, or 360 degrees. So most periods are going to be 2 pi. So for example, if I start here at 0, I go up and I end here at 360 degrees, that's one full cycle in a 360 degree period. So that means my period is 360 degrees. However, sometimes you're going to see this. And so what just happened is that I have 2 full cycles. There's one cycle, and it ended at 180 degrees. which means that my period is now 180 degrees instead. And in addition to that, it means that how many cycles do I have in a 360-degree period? I have 1, 2. So I had 2 cycles in a 360-degree period. So that's going to be the frequency. See here, this would be my frequency. That means how many times am I going to see it? So again, what if I did something like this and I started 0, I went 1, 2, 3, and here's 2 pi. That means I have a frequency of three graphs in 360 degrees, which means that a full cycle, 3 divided into 360 is what, 120? So that means each of these is 120 degrees. Of one period would be 120 degrees. Okay, so on your Desmos investigation, you would use the slider. So after you typed this in right here and go to Desmos, what would be the effects of A and F? Now A, in the other screen, I told you that was your amplitude. And what that's going to do, amplitude, what it should do is it should take your graph, which is let's just stick with the sine wave. Here's my sine wave that goes up 1, down 1. And if I'm changing my A, which is my amplitude, it could do something like this. If it's a positive high number, that's what it's going to do. It's going to change the height. Instead of it being 1, it might change it to 5. So the amplitude is going to change. Now, keep in mind that you also could have a negative amplitude, not amplitude, but a negative number in front of the amplitude, which is an absolute value. And what that does is it drops it down first instead. It's still a positive, A is still positive. It's still an absolute value of that number, but the negative sign does reverse it and drops it down and reflects it across the x-axis. Now the F is what we just talked about. That's the frequency, meaning I could have 1, 2 graphs, so that I could have 2 full sine waves in a 360 degrees. So that'll change that value. So what you could have done, what you should do right now is basically plot all of these points, plot all these graphs on Desmos. And you can pause the video and then come back to it. But basically a sine wave is going to start at 0, go up, come down, end at 0. 360 degrees is my period, or you could also say 2 pi. How many cycles? In this case, because of the x, we're going to stick with 2 pi, okay, not 360. How many cycles? We have 1 cycle. This graph right here, meaning, see, this is the F. The F is changed. That means that's my frequency is changed. That means in a 2 pi period, okay, here's pi, I have 2 full cycles. That means it goes 1, 2. So I have 2 full cycles in a 2 pi. And in this case, my period is not 2 pi anymore. My period is now what? You should say pi. For this one right here, you've got 3. So let's see here. And if I start at 0 and I go, oops, okay. And if I start at 0 and I go up 1, 2, 3, okay, still 2 pi, that means the distance it takes for me to start and stop 1 full cycle right here, all right, that full cycle right here is 2 pi divided by 3, so that's 2/3 pi. And 2/3 pi in degrees is 120 degrees. So the length of time it takes for me to start and stop is 2/3 pi. I have 3 cycles. My period is 120 degrees, or 2 pi over 3. And lastly, we have y equals sine of a half x, which now my frequency is 0.5. So if I draw my graph, this is called the original graph. We call that the parent graph. So I draw my parent graph, but what that means is this is 2 pi and this is pi. It means that my frequency is half. So think about this. If my period is 2 pi and I divide by my frequency, which is a half, that's going to give me 2 pi times 2 over 1, which is 4 pi. And and 4 pi becomes my period. So what that means is that this needs to be longer, because now here's 4 pi. And so what that means is that the length of time it takes for me to start and stop, so sine starts at 0, ends at 0. Halfway in between, it crosses. So halfway in between it crosses, its height is 1, and the minimum is 1, negative 1. So my graph actually, see how it's widened? The length of time it takes for me to finish my graph is now 4 pi. The period is 4 pi. How many cycles do I have in a 2 pi period? I have a half. Okay, so that's what it is. So now we're going to So now we're going to look at this. I don't know what just happened. Y equals a sine x or a cosine x. A being my amplitude. So if this is my amplitude right here, this is A. Now my frequency here is 1. I don't know if you can see that, but that's my amplitude. That's my frequency. That's my amplitude. My frequency is in between here and here. So that's 1. So if I always start off with my parent graph. Okay, so if I start my parent graph, sine starts at 0, ends at 0. Halfway through it goes to the 0. Here's 1. Here's negative 1. So my sine wave is going to do this. Okay. Now, A is my amplitude. And what that means is it's kind of like you're multiplying by 2. So 0 times 2 is still 0, still 0, still 0. But 1 times 2 is 2. And if you think of it, that's my height. And negative 1 times 2 is actually negative 2. So really what my new graph is doing is it's going up, still going through 0, 0, and comes back up like this. Cosine of this is a half. My amplitude is a half. So let's think about cosine. Cosine starts high and ends high. Halfway in between, it has a low point. Halfway in between here, it crosses pi over 2 and 3 pi over 2. So cosine does this. Starts high and it ends high, like that. Now, the 1/2, what that does is it takes my amplitude and it cuts it in half. So we're going to have this little value here, here, and here. So my amplitude now is like this. So it's a little bitty graph. Okay. Now this is a little bit tricky because even though my height is 1/2, this negative sign reflects it across the x-axis. So let's start with a sine wave. Sine wave starts at 0, ends at 0. Halfway in between has a high point. Halfway in between has a low point. So draw your graph. Okay. Draw the amplitude is a half. But in this case, remember this negative sign reflects it across the x-axis. So it's a half and it's a half. So it's still going through my zeros because 0 times a half is still 0. But this is going to go down first, okay? And then, oops, that should be up on top. And then come up first, like that. Okay. Cosine graph. Cosine starts high, ends high. Halfway in between has a low point. Halfway in between that crosses 0. Halfway in between that crosses 0. So it's going to do this. Okay. Now, this negative sign is going to reflect it across the x-axis. This 2 is, instead of cutting it in half like this one did, is actually multiplying by 2. So not only am I reflecting it, I'm also going 1, 2, 0, 1. Instead of this being down 1, it's up 1. Okay, so instead of that, that's 2. This still 0. And this one, let's see here, is reflecting down. So it's going to look like this. Okay. What about this? This is my horizontal shift. We also call it a phase shift. Okay. I like to call it a horizontal shift, but that's what the constant H, what that does is it moves my graph left and right. And in this case, see this plus pi over 2, just like the opposite of that, that's what it's going to do. It's going to move it to the left, pi over 2. Okay, so cosine graphs start high, and let's say end high. So halfway in between, we have a low point. We cross a 0 in between those, and so we have a cosine graph that looks like this. Okay, and moving it to the left, think about this. If this is 0, and this is 2 pi, and this is pi, this value right here is pi over 2. So this distance from here to here is pi over 2. So what this is telling me is my graph is going to move left pi over 2. So everything is shifting that much, that distance, this distance. Everything is shifting this distance. So this will go here. This will go here. So now my new graph will go through these points, and it'll go like this. Okay, that's a shift. Moved everything to the left, pi over 2. This one on the right, this says cosine of the quantity x minus pi over 2. So again, start high, end high. Halfway in between, we have a low point. Halfway in between those, we cross 0. Goes like this. And because it's a minus, that means we're going to move to the right, pi over 2. So for this problem, everything is going to move to the right, pi over 2. So everything moves over. And so my new graph is going to start here at pi over 2, come down, and then, of course, and you can't see the rest of that because that's off page. So the last shift that we're going to talk about today is vertical shifts. And vertical shifts either can be, either adding or subtracting, or excuse me, adding in the front or adding in the back, but you also can subtract. So a cosine graph, again, starts high, ends high. Halfway in between, we have a low point. Halfway in between that, crosses the x-axis, and it's going to look like this. Now, this says cosine of x minus 1/2, which means that, see this being 1, it means that I'm going to drop it down 1/2. So everything's going to drop 1/2 of a unit. And so my graph now looks like this. This graph here says sine of x plus 1. So remember, sine waves start at 0, end at 0. Halfway in between, they cross at 0. Halfway in between that, they have a high point. Halfway in between that, they have a low point. So they start at 0 and end at 0, like that. So this plus 1, what that's doing is moving my entire graph up 1. So instead of starting at 0, I start at 1. Instead of starting at 1, I start at 2. Instead of starting at 0, I start at 1. -1, I start at 0, and 1 and 0, I start at 1. So now my new graph will move like this. So how do you like sinusoidal transformations so far? They're fun, right? Okay, so this is kind of a trick question. Here's the question, or here's the answer. What's the question? So let's see if you can come up with the equation for this. Both of these two equations have a period of 2 pi. That means my frequency is 1. This starts at 0, goes through 0 here and here. So this must be a sine wave. Let's look at the height. See, this is 5. That's my height. That means my amplitude. So what you can remember, I'm not sure if you remember this, but my VAF graph, so vertical shift plus my amplitude times sine of my frequency, x minus h, that's the equation of my VAF. That's my mnemonic, VAFHP, VAF. P stands for period. So my equation is, and by the way, I do like it when, and you're going to be doing this when I get back, but I like to put the VA FHP on the side. Now, it doesn't look like, see how I can do this here and put it right on the axis and see how it's symmetric top and bottom? There's no vertical shift here. My amplitude, though, it looks like it's 5. I have my frequency, because my period is 2 pi, we have a formula for a period. Period is equal to 2 pi over my frequency. And if my period is 2 pi, that means my frequency is 1. I don't have a horizontal shift because it starts at 0 and ends at 0 unless I actually want to make this a cosine graph. And then it would be a horizontal shift to the right, which means that would be minus of pi over 2. But we're not going to do that right now. We're just going to do this easy. So we have y equals no vertical shift. That's gone. My amplitude is 5. Sine. My frequency is 1. I have no horizontal shift. So it's x minus 0 or just x. So this would be the equation of my graph. Okay? That's kind of cool, huh? This one right here starts at 0, ends at 0. No, actually, sorry about that. Starts high at 1, ends high at 1, halfway in between. We have a period of 2 pi. Do we have a vertical shift? Let's see. Halfway, this is symmetric. No vertical shift. My amplitude, this looks like it's -1 to 1. So my amplitude is 1. So this one is actually just y equals cosine of x. We didn't have anything change. So welcome to Sinusoids, and I hope that helped. Finish your homework, and I'll see you soon. Thanks. Bye.